What is this? I see the face. Yeah, this is the one. Why did you say that? Okay. Oh, there's something. Oh, you know. Why is something different?
And then you guys have about 20 minutes. So still plenty of time. So just take your time. Then there's about 12 minutes left. You guys still have plenty of time though. And then you guys have 5 or about 6 minutes left. They have just about a minute left. All right. And then time is up. So what we'll do is we will take about a 15-minute break. So just to make it even, or just to, I mean, way a little bit over 15 minutes, but we'll say, was it 8:20 now? Call it 8:20 now. So 25, 30, 35. Just come back at the 35 minute mark. And then what we'll do is we'll go over the quiz. We'll do a weather brief, kind of see where we're at there. Maybe take like a small little break, just depending on what time it is when we come back from doing all that. And then we'll just jump into the whole charts a little bit. You'll get more of a big review from Dalen. He's going to be talking about like those alternates, and he's going to be going over the approach chart. So we're not really going to hit too much onto that. We're just basically going to go over the 10-9 and then just go over the takeoff and takeoff alternates for tonight. But we will report back at the 35-minute mark. All right. Everybody getting back? Perfect. How'd you guys think you did on that quiz? Pretty good? Okay, awesome. So we'll go through it really quick. Again, you guys have the opportunity to retake this if you didn't get an 80% on it. So you can take it as many times as you need to get that 80%, or if you just want to, if you did get the 80% or higher, you didn't quite get 100%, you're always more than welcome to retake it, or just write down maybe in your notes, so some of these answers that you've gotten wrong, just so you guys have the correct material to study. All right. So we'll start at the first question, which is going to be, how often are METARs issued? Everybody should know this one, hopefully, because we covered it, but it's going to be every hour. And then again, if I'm also going too fast, just let me know and I'll slow down. How often are TAFs issued? It will be every 6 hours. How long are TAFs valid for? It's going to be 24 to 30 hours. What are the 5 things that are required to be reported in a METAR for dispatch purposes? We have the wind direction, the speed, the visibility, sky condition, temperature, and altimeter. And then when would a SPECI be issued? It's going to be any significant change in weather conditions between the normal scheduled METAR reporting times. What is the correct abbreviation for an urgent pilot report? It's going to be UUA. So umbrella, alpha. And then decode the following wind report. It's 270, 65, gusting to 80 knots. That's super high. But the winds are coming from 270 at 65 knots, gusting to that 80 knots. And then based on the wind report, 270, 65, gusting 80, from which direction is the wind blowing from? So it's going to be from the west to the east. And then why do dispatchers avoid filing flight plans into or around volcanic ash? Basically, it's going to be that high temperature inside the engine. It causes the ash to melt into glass that sticks to the critical parts and then potentially causing that engine failure. And then what is being reported in the following PIREP? It's that UA and then the over FSM with the turbulence moderate. So it's going to be moderate turbulence. And then what does the OVFSM in the following PIREP represent? It's going to be over the FSM VOR. And then using the following winds, aloft forecast, which station is reporting winds from 230 at 104 knots, temperature is negative 49 degrees Celsius, is going to be PUB, so Papa Unicorn Bravo at 34,000. And then if an aircraft has a deferral for an anti-ice system, is the aircraft able to depart in the following conditions? The answer should be no. What's the difference between an air mat and a SIGMA? The air mat is potentially hazardous condition to light to moderate in severity, whereas SIGMAs are severe. And then what is CAT? It's clear air turbulence, turbulence without any visual cues. What is the definition of a tempo? It's temporary weather conditions that last for less than half of the tempo time period for less than an hour at a time. That's always a tongue twister, that one. And then tempo in a TAF is merely advisory. It does not have to be used to determine whether an alternate is required, excuse me. That is false. And then when a tempo is included in a TAF, the weather conditions in the tempo time frame replaces the main body. That is going to be false.
Isn't that true though?
When the temperature
I hear you,
or when
man.
the
I did the
tempo
same
language
thing.
is included in a TAF, the weather.
It
No, it will
contradicts
never
the
be.
last
It will
question
never
that
be
you just
true.
read.
Yeah, it's never going to be true. For the tempo, you can never use that as a to like dispatch. Essentially, you have to always go back to like the main body to figure out what the actual weather is going to be doing. Noah.
Yeah, I'm kind of confused on that one too, because I could have sworn we were told like if in the main body it was like 1 mile one statute mile, but our time frame falls in the tempo and it's like a quarter statute mile, we have to go with whatever's worse. So it doesn't necessarily take over, but we still got to use it though, right? Yeah, that's
I mean, yeah, that question directly contradicts the last one, the last answer, which was that it's not just an advisory, it's something that you have to use, take into account for like legal to go and whatnot.
Okay, let me see if I can think of how to word this. Because the tempos can be so confusing when it comes to like figuring out if like you can use that for like legal purposes and stuff like that. So hold on, give me 1 second. Let me just reread this to make sure I'm saying it right before I say something. Okay, so the first one where it says that the tempo is in a TAF is merely advisory. It does not have to be used to determine whether an alternate is required. It was false. Does not have to be used to determine whether an alternate is required. So so for the tempo though, if you are dispatching a flight out and let's just say it falls into that tempo line, there are certain exemptions that you can use, but you don't know about those until you go onto the job. It's not something that is taught while getting your certificate, if that makes sense. So there are certain like exceptions that you can actually use with that tempo being in that, like where it falls into like the line of when you're going to be landing at your alternate or at your destination. But you still have to use your main body. Like your main body still has to meet that criteria of it being above that 1, 2, 3 rule. And then you would need essentially another alternate on top of that, which doesn't necessarily have to be that 1, 2, 3 rule. It can be like below it, if that kind of makes sense. But that's something that you learn on the job. So for here, let's see, other conditions. And temporary is included in a TAF. The weather conditions and temporal time replaces the main body. That should be false. And then the first one, it does not have to be used to determine. Yeah, I'll ask Jaden about that if it seems like it's contradicting itself, because I can kind of see like where your standpoint is, where it's like, oh, well, the first one is saying that it's an advisory, and it doesn't have to be used to determine if that alternate is required or not, like how that can be true versus false. I'll reach out to Jaden though on break, and just ask him to clarify those two ones.
Okay.
Because from my understanding, you can't use a tempo to determine, you can't use your tempo as like your main your main body essentially. Like you can't, if you're coming into your destination and there's a tempo issued at that time, you cannot use that tempo when you're dispatching. You have to use the main body to determine if it's legal to go or not.
I think that's only if it's less restrictive. If the tempo is more restrictive, how could you ignore it? If you're landing during that time period, if it's more restrictive than the main body, you would have to use that to determine legal to go. Like, why even have tempos then? I mean, if it's less restrictive,
Yeah.
I can see, yeah, you use the main body, but if it's more restrictive, if it's lower visibility and lower ceilings in the tempo, that would have to be used to determine legal to go.
Well, you don't know, but if you think about it, you
That's
don't
what
know
that's
when
what we were
that,
taught in the class. So
that's what you were taught. Okay. I will reach out to Jaden just to confirm those two, to ask for clarity on it then. So I'll get back to you guys on that one, if that's okay. Okay. So then just scrolling down, I'll make note of that in just a moment here. Okay. So then what is being reported in the following PIREP is going to be low level wind shear, 20 knot tailwind during descent. And then what is the wind value and direction of the following wind is 75 knots from northwest to southeast. And then that little symbol, that orange one, that's like boop, boop, boom, that's turbulence. The other one that's kind of more of like a maroon color, like a reddish color, is going to be icing, where it's like a U and it has like the 3 stripes in between. I don't know if your guys' questions are like the same order as mine, which is why I'm just kind of just like talking about this.
Yes,
And then
so
the
I'm
symbol,
keep jumping around. Sorry.
you keep on jumping around. Okay.
Yeah.
I was like, I don't know if it's like in the same order or not. So I'm trying my best to like explain the symbols here. And then the symbol that has like the 2 triangles and that's blue is a cold front. And then the ones that are red with just like a half circle is going to be a warm front. And then where it has the cold front and the warm front symbol, it's going to be a stationary front. And then the symbol that represents an occluded front is going to be the purple, and it's both a cold front and a warm front, but it's purple. And then the symbol that represents a trough is just going to be those like dashed lines. They're kind of like dark yellow, I would call it, maybe like a mustard color. And then the dry line is going to be those, I don't even know what color this is. It's like an orange-ish, like a dark orange one, but it's the half circles. And Riley said, would it be possible to share my screen? I can absolutely do that. Let's see.
I'm just teasing, by the way, on my comment.
Oh, I didn't even see your comment. To draw them, I mean, I can. I'm just not a good drawer. Let's see. Okay, show my screen. Perfect. All right, so this is going to be that dry line, and I'll kind of just circle back just a couple months ago. That is going to be the trough, that occluded front, and then the stationary front, the warm front, and the cold front. So we're going to continue scrolling down. All right. So in this, I'll leave the chart up. For shallow, right, the abbreviation is going to be MI. So Mike India. For mist, you guys all know that one. It's BR, baby rain. For spray, it's PY. Smoke is FU. In the vicinity is VC. And then thunderstorm is going to be that TS. And then if you guys have seen snow, SN means snow. RA is going to be rain. GR is hail. And then the PL is going to be ice pallets. Everybody good on those so far? Perfect. We'll scroll down. So then what's the main difference between air mass thunderstorms and frontal thunderstorms? The air mass thunderstorms, they develop and they leave fairly quickly. They're motionless and they're easier to avoid, whereas frontal thunderstorms, they may be long-lived. They move along a cold front and are harder to avoid. And then determine if you're legal to go if you have a high minimum captain, and if your destination alternate is required. So we put not legal to go, or it's not legal to go, and an alternate is not required. And then the method 2 drift down is a takeoff at a weight that if an engine fails during cruise, the aircraft can descend to a suitable alternate. And then while being able to clear all obstacles by 2,000 feet within 5 statute miles of either side. Then what's the definition of a contaminated runway? It's more than 25% of the runway surface is covered in more than 1/8 inch contaminated. And then according to the FARS, when does a flight require a destination alternate to be listed on the dispatch release? And it's always going to be required, except for that 1 hour before or after ETA. There are at least 2,000 feet in ceilings and 3 statute miles visibility. So that is the quiz. Everybody good so far in it? I know I'm going to come back, circle back to that tempo language. But hopefully you guys all, if you got something wrong, you marked it. This way you can just, your notes are correct, or if you have to retake it, you can retake it. But I will circle back to the whole tempo. All right. So now that that is out of the way, yay for quizzes. We are going to be on the aviationweather.gov website. We're just kind of going to go over just like what's happening right now. Do like a little bit of a weather briefing, since that's essentially what you're going to be doing when you're on the job. If you choose, of course, be a dispatcher after this. So we're kind of just going to go see. We're going to look at all the different weather products there is. Probably hold off on meters and taps unless you guys want to read a couple of one of those. That's fine with me. But we are going to start with, So underneath products, you have the SIGMET and the GMET, or the AirMat, sorry, and the SIGMET. So we're going to just kind of take a look into this because there's a couple things happening right now all over the place. So does anybody want to just kind of give me a brief as to what you see right here on the computer screen? And of course, I'll click onto them so you can kind of also see what's happening as well, like the top, the base of them. Anybody? So in this case, we have some high turbulence happening, right? Kind of down in the Georgia area, a little bit of Florida into like the Texas area across, I don't know what you want to call it, central United States, not even. So if we click on to it, right, it's going to be the base starts at 18,000, top goes up to 38,000, and it's moderate turbulence. Same thing over here, the base starts at 30,000, so a little bit higher, and the top goes up to 43,000, and there's some moderate turbulence. So if you're dispatching a flight out and they're kind of going down here, like down, passing by Georgia, or maybe going from like, Georgia to the west side of the United States, at these altitudes, they are going to be expecting some turbulence, some moderate turbulence, right? Let's see, we do have some icing conditions, which we'll go into the whole icing weather and or the whole icing tab in just one moment here. But we do have some icing conditions happening. Let's see. Over here, we have a base, starts at 12,000, goes all the way up to 20,000, and it's moderate icing. We do have, I believe, some IFR as well. So we have some turbulence again, 18,000 to 43,000, moderate. Let's see, we have some IFR happening. We have a lot of turbulence happening all over the place right now. So base starts at 24, top is going to be at 36, moderate turbulence. So it's kind of going to be like a bumpy ride anywhere you go, it looks like. And then if we go down here.
Jennifer, real
Yes.
quick. Up in the northeast, like up, looks like past Maine into Canada, that mountain, is that mountain obscuration or is that mountain wave turbulence? What is that in that red box up there?
It just means like some like visibility restrictions happening. So mountain obscuration by clouds.
And then low turbulence, is that, so the high and low turbulence is at 18,000 feet? Is that the graph for that? As far as turbulence high,
I
is it anything
believe
over
high
18?
starts at, yeah, I want to say high starts at 18,000 and it goes
That makes
up
sense
and
for the
then
high
turbulence
structure.
is lower. But I can double check on that one. Because right here, if you see the turbulence low, so it starts at the surface and it goes up to only 5,000 feet in this area, and it's moderate turbulence. And then we have some low level wind chill as well over here. And they reported airspeed loss or gain of 20 knots or more below 2,000 feet HEL. And then you have that, okay, yeah, so the high turbulence starts at 18,000 and then low turbulence would be 18,000, or I guess you want to call it 18,000 and below. And then the high turbulence will be like 18,001.
Okay, thank you. They made it make
Yeah.
sense.
Yeah, of course. So you had definitely a lot of turbulence over here. Oh my goodness, where am I at? A lot of turbulence. Looks like a lot of visibility restrictions over in the mountains. And then since we're kind of just like on the subject of icing, I'm just gonna kind of jump over to that icing tab before we look at like those prog charts, of course. So if we go to icing, there's a lot of stuff happening, and there's always a legend here too, like in case you want to kind of know, like, oh, is there like what these colors mean? So like a trace, light, heavy icing. And then they have the pyreps over here as well. So the legend, I like using the legend, especially when I'm just like, oh, like I'm unsure about what, like what exactly it means in a way. So we have a lot of icing up here. The base starts at 9,000, it goes all the way up to 18,000. If we go over here by Denver area, or like the corner of Denver, it's going to be the base starts at the freezing level at 9,000 or to the surface, and it goes up to 20,000. So there are some icing conditions over there. We looked at this one as well, where the base is 12,000, it goes up to 20,000. So a lot of different icing. And then we also have those pyreps over here, where it talks about the icing over in the Georgia area, looks like. So this one's over Atlanta, and it just talks about that there's a light chop. Oh, it talks about icing is negative. I don't know why they put that there, but that's good to know that there's nothing really happening over in Georgia. But we can kind of see that there's a lot of icing in those like mountain areas, and then we're like the kind of not Central Florida or Central America, because that's kind of more here, but a lot of icing like around it happening. And then your favorite one is going to be our Prague. So who wants to kind of give a brief about what they see here? What kind of front, or what kind of systems do they see, or what kind of fronts they see? And if you want to just name one, that's fine as well. But who wants to kind of talk a little bit about what's happening right now? Anybody? Brian?
Okay. So
Hope that's clear.
So okay, so we've got, let's see, there's a front, a cold front coming down out of Canada around North Dakota. It looks like there's some rain and snow and ice out ahead of it. And then off to the northwest, looks like there's some snow showers, but it looks like, I mean, there's areas of high pressure, but also some troughs. And then we've got a cold front stretching across from California over to around, well, I guess to the central US, and then another stationary front extending down across over to Tennessee. And it's, I don't know, they may not, I mean, there doesn't seem to be any precipitation around them, so they may be kind of weaker systems. I mean, or at least not a huge contrast maybe of cold and warm air, but and then high pressure in the northeast.
Yeah.
Yeah.
So
I guess,
what kind of weather do you think what kind of weather do you think is all going to be like kind of around that central upper United States in this area?
well, I mean, looking at the
I can zoom in a little bit.
Yeah, the isobars are kind of closer together, especially over in Colorado. So that could indicate some stronger winds, and maybe that's probably causing some turbulence.
Yeah, which explains why we saw those air mats for those turbulence, right? Is because over here, those isobars, the closer they're together, the stronger like winds you're gonna have.
Yeah. So it looks like it's pretty dicey going over Colorado, probably.
Yeah, probably. It's dicey a little bit everywhere, it seemed like earlier. Perfect. So then let's just say anybody else, right? We're going to move on to 6 hours. So at 0600 UTC time, of course. Now we went from like everything was a cold front over here. We have some stationary fronts. We have that cold front. We have that occluded front, it looks like. And now we jump ahead, and it doesn't really look like much has changed in a way, but I do see some changes. So we have that stationary front. It's going to be moved down. We have that cold front that's going to be moving down as well. That occluded front came down, and then have a warm front moving into a stationary front as well, or a warm front that turns into a stationary front kind of over in the Atlanta area. And then if we go a step further, right? Now we have stationary front seems to stay the same. It looks like we have that cold front moving down. That occluded front is, it looks like it might be okay. Everything seems to be moving down, right? Everything's getting pushed down, it looks like. And then we're going to take things a step further, because this is what you're going to really do when you're on the job training, of course, or when you're on the job, right? Is you're going to look ahead, not just like for that day, is to look like to see what you're going to be battling with that day. But if you're working 3 days in a row, you kind of want to see like, okay, well, what is the weather forecasted to be? So if we kind of take a step further into it at 1800 UTC on February the 10th, Tuesday, so tomorrow. Oh, where did I just go? Let's see. Now that cold front really comes down into the central of the states, right? You have the stationary front, that occluded front is getting pushed more towards like the southeast area. We have some high pressures off to the side here, high pressures in the Florida area. So then in this case, right over here where this cold front, excuse me, is, what kind of weather is central United States kind of going to be looking at?
Rain.
Yeah, rain, good visibility, of course. Let's see. It's gonna just think everything's getting pushed, right? So like, I don't know if there might be some thunderstorms happening, but pretty much like rain, some gusty winds. Temperatures are probably going to be dropping before this comes down. And then let's see. And then if we go a step further, again, if you want to have that legend, there's always that legend. So now you have some rain happening, which makes sense because of that cold front coming down. Up here, let's see. You have some ice, and it looks like a mix of ice and snow over here in the north area above Philadelphia. One thing you're going to learn is like you'll get good at your states. If you don't know them that well, you'll get good at where every state is at. And then if we continue to go further into it, that rain again is going to be coming because now you have that cold front coming up here. It looks like that occluded front is going to be pushing off to the side. So kind of getting off the states. You have that warm front happening over here. And you have some more rain coming through. Looks like maybe that's like a little bit of a stationary front right there, but you have that low pressure system as well. So that will definitely cause it. So it looks like if we're just kind of going through this, it looks like there's going to be a lot of just like cold fronts hanging out, a lot of low pressure systems hanging out, some stationary fronts as well hanging out. So if you kind of just continue going through, you can kind of see like the different changes that's going to be happening within the next couple of days into like the week. So expect to maybe not have the best kind of weather. But yeah, that's pretty much what you would do when you're doing like a weather briefing. Is you're going to be looking at those prog charts. You're going to be looking to see if there's any airmints or segments out. Of course, you can look to see like what the winds and lofts are doing. You can look to see like what some TAFs and METARs are doing. If we go into observations here, let's see. And just zoom into a couple of these guys. If we come over here, Nevada is showing 10 statute miles. It's broken at 7,500, so 7,500. It's overcast at 9,000. So pretty much, I mean, nothing to be too concerned about. At least I wouldn't be too concerned about any of that stuff. And if we come up here in Rapid City, South Dakota, its visibility is at 10 statute miles. Overcast is 3,800. So I mean, that was 2 hours and 17 minutes ago, though. maybe things have changed since. But you can kind of look to see like most airports, they are VFR. Oh, let me get out of there. Most airports are VFR. If we come up here to wherever International Falls is, looks like there's some gust for winds. So the winds are 11, gusting 17, 10 statute miles, overcast layer of 2,300, so 2,300. And you have it, temperature is 2, dew point is -2. So they may be experiencing some type of like fog happening there. But that's pretty much just what you're going to do when you're doing like a weather briefing, of course. Of course, you can kind of see like what the clouds are doing as well. I don't know how much you guys utilize the aviationweather.gov website, like how much you went into depth with it before. But it has some really good resources here. And then, I mean, the winds, you can kind of see what the winds are doing, of course, what direction they're blowing at. Up here, you have that low level wind shear, which is what we saw earlier as well. You have over here, surface winds is greater than 30 knots. I don't know exactly where that's at. It looks like it's off in the coast somewhere, off to the side of California, but that's pretty much how you're going to be doing a weather briefing, what you want to look for, what you want to get yourself into like thinking like what type of weather you're going to be experiencing, or what's something that you may like. If you notice that, especially it's like winter operations, if you notice that one area is going to be in like some snow, you might want to be like, okay, well, we have to look at to like our alternates, be prepared to add extra fuel on board, things like that. And if I'm not mistaken, I believe, I don't know if they showed you it or not, but they also have, they changed everything around since I've used some of the stuff. But they also have like the terminal weather dashboard, kind of what to expect, things like that as well. So it's good. It's a good tool to use, the aviationweather.gov. But again, like you'll kind of utilize more resources that are going to be available to you guys on the job training. But this is just something I would kind of just get into the habit of looking at. I believe, if I'm not also mistaken, that during the rest of the course, you guys are going to be doing like a weather briefing every single day. If you haven't already, correct me if I'm wrong on that one. But that's pretty much it for the weather briefing that I do. So we will then, let me kind of get my thing in order really quick. Sharing. Okay, we are going to jump into the 10-A, the airport page. So I'm going to just close out a couple of these tabs, kind of get myself organized just a little bit better. All right. So in your drive, you should, if you guys all go to your shared drives, we're going to kind of just do this together in a way. If you go into your shared drives and go underneath flight planning, and then underneath Jefferson charts, you should have all your charts available that you're going to be using in this course. Does everybody have access to that? Okay, cool. So when we go into, let me pull one up. Give me one moment. Okay. So when you go into your shared drives underneath the dispatch course, and underneath the flight planning Jefferson charts, right, you're gonna have all your Jefferson plates on there. So one of the things that we look for, I pulled up Salt Lake City for this one to review. Is it's gonna have like a lot of information, right? It's gonna have like an overview, it's gonna have a nice, pretty little picture. It's going to have that 1902, just talks generally about the airport itself. And then, to be honest with you, I've never seen somebody put the weather in here for the months, but I guess Salt Lake City did. And then you have the 10-9. So there's a lot of, let me just kind of zoom that in. So there's a lot of important information when it comes to the 10-9 charts. When we talk about takeoff alternates, when we talk about taking off, like the requirements that you have to have for like the visibility, things like that, you're going to be into these charts when we talk about your landing minimums, or excuse me, let me back that up. Your alternate for your destination airport, you're going to be on here. When we talk about our alternate, our takeoff alternate, we're also going to be in here on the 10-9. And I'm going to show you guys kind of how it's broken up in just one moment here. I have like a little article resource that kind of breaks everything up in a way. Very simple, keep it very simple. But you will be utilizing the 10-9, 10-9A, right? There's just a lot of information on the charts. Of course, have your oh, give me 1 second. See, okay, just making sure everybody's still with me here. It's going to talk about your different arrivals that you have. Basically, if you haven't looked into this, this is just what you're going to be going through here in the next, I think you guys started at the end of this week, if not the beginning of next week, the whole flight planning. I think the route building is this week though. But basically how you're going to be choosing your different stars, your SIDS, everything like that. And then eventually you'll get to the whole approach plates, your instrument approach plates, right? So for this class, we don't use those RNAVs. So you're only going to be really using the ILS or the localizer. And again, Dalen's going to go into more of this though later down the road this week. But pretty much it's going to have everything that you need right here in your drive of what you're going to be looking at. So for today's focus, I'm going to just scroll back up here. All right. And I have this resource from Bold Method. Bold Method is a great website that I like to use just because it keeps everything very simple, very clean. One thing we don't want to do is overcomplicate something. And when we get into the whole like landing minimums, your 1 nav aid, 2 nav aid rule, which I'm not too sure if you guys are familiar just yet with those, it can be very easy to kind of overcomplicate stuff. So we're going to be looking at a couple different resources today. So one of these, which I will make sure to link it into the chats as well before we go, or when we go on our next break. But it talks about how to use the Jefferson 10-9 airport page. So I'm just going to first by starting off on this resource to kind of break things up, just because I think it's a little bit more simpler than looking at my screen and kind of like trying to show you what each thing is. So this is what it would be, which is what we saw, which is this guy. So they're using Colorado. I just have Salt Lake City pulled up. It has the airport diagram over here. It has the airport diagram for Colorado. So it has your runways, the length of your runway, the width of your runway. It talks about if there's, in this case, the Colorado one that they use, that there's glider operations in the vicinity of the airport. There's large birds around the airport in the spring and fall. And the runway 10 right, or runway 10 right traffic pattern. And then it talks about closed to unscheduled airport operations with more than 30 passenger seats except prior permission required. So it's going to have a lot of stuff. What we're going to be focusing on is this, which we'll learn just in a little bit, which is for filing as an alternate, and our takeoff and obstacle departure procedure, and any additional runway information. So basically the 10.9 is broken into, it's the same format, but it's broken into 5 primary sections. You have the heading, communications, airport plan view, additional runway information, and takeoff and alternate minimums. So again, when we talk about alternate minimums, we're always going to look at, and we're talking about takeoff and alternate minimums, whether you're doing a takeoff alternate or a landing alternate, you're always going to go into the 10-9. Everybody with me so far? Thumbs up, thumbs down if not. Okay. So up here, they have the heading, communications. It's very simple. Basically, like, you know, what your radios are, your airport plan view, which you'll be using the airport plan view as well when you're determining which runway that you want to plan for to like take off in. Additional runway information. And then the bottom half is your takeoff and alternate minimums. So basically what the heading consists of is exactly what it says, right? It consists of about that airport identifier, the airport's elevation, and the lateral and longitudinal location. And then communications, exactly what it says. The next up is the communication section. It's pretty straightforward, right? It just talks about what your ATIS is, what the radar or the tower, the Unicom is, the center is. And then that airport plan view, we kind of already talked about it. Basically, it talks about like the taxiways, the ramps. It just gives you that big picture of like what the runway, how long they are, what the widths are, if there's any, like what the taxiways are, the elevation. And then our additional runway information is basically going to be just like details about what the runway is, right? So it's going to talk about like what kind of pavement there is, which is, you'll notice that when you start doing the whole flight plan, this is something you're going to have to make note of when you're planning like certain runway, is what the surface is. So if it's grooved, if it's asphalt, there's a couple of other ones, but you'll have to kind of look to see like what the surface is and put that down as well. It talks about the runway lighting, the approach lighting details, the visual glide slope indicator lights, and then the usable runway lengths and widths. And then your takeoff and alternate minimums. So again, like before, we're basically always going to use this when we're talking about where our takeoff is, where our landing, if we can use this for a takeoff alternate airport, because there may be some that you can't actually use that for an alternate. So you have to think outside the box and figure out like what airports are nearby that you can actually use instead. Same thing with like a landing alternate as well. So we'll go into more depth about that. And then some of them, they just have numerous 10-9s, right? Because some of them are just so big, like Denver, Colorado is pretty big. So it probably has multiple pages of that. You can kind of see all the different runways that they have, where like the terminals are, and then where like the de-icing pads are in relations to the terminals. So we'll kind of look into Denver a little bit more, just of that overview to kind of see. So then they start label it a little bit differently. So instead of it being 10-9, it would be 10-9A, which we'll go into this well, we're looking to Denver a little bit down the road today. But that's pretty much how your 10-9 is set up. Is broken into. Everybody good so far? Okay. Like I said, I like to just keep things very simple, not overcomplicated. So that's what we're going to do. Tomorrow, I don't know if some of you guys weren't in when I was talking about it, but tomorrow Allison will be in. And she's going to be going over NOTAMs and how when you have certain things that are out, like certain lighting approaches and stuff like that, it increases those minimums. So she's going to be diving more into depth about the different, like what you have to add to get to like the minimums, things like that. So she's going to be talking more in depth about this. I'm just basically giving you a very basic, simple foundation that we can build into later on into the week. So right now, I know we just took a break about an hour ago, but you do get a break every hour roughly. So right now it is 9:26. We can do is we'll take like we'll just do a 15-minute break. This way, if you guys haven't finished eating some food or you're hungry, you need to heat something up, you can. But we'll just take a 15-minute break. And then we're going to just dive into exactly more what we're looking at for the 10-9 and talk about those takeoff, the standard takeoff. And if it doesn't meet that, what we can take off in, what we need an alternate for. So let's come back. It is 9:27. We'll call it 30, 35, 40, 45. We'll say 9:45 we'll come back. Or 9:45 is my time, 9:27. So at the 45-minute mark is when we'll come back and then we'll start up. I'm so used to just saying my time, but I keep on forgetting everybody's in a different time zone right now. All right, cool. So 45, and then we'll come back. All right, everybody back. Perfect. All right. Everybody can see my screen pretty well. Awesome. So diving into the whole 10-9. At the top here, so I'm on Salt Lake City once again. So at the top here, you can see it's the airport identificator, Salt Lake City, the airport elevation, right? And then we have the 10-9. So that's ultimately what you want to look for. And then we have basically just like the ATIS information, the comms over here, Salt Lake City, like the clearance. We have the different comms for the ramp control. So like the west, 1 west, 2 west, 3 west. Basically the ground and the tower, what frequency they want to be on for what runway. At the bigger airports is where you're going to be seeing this. Like on the small airports, you won't really see it that much. And then we have, oh, let me go back here. I don't know why it keeps on doing that. Okay. And then we have the overall picture of Salt Lake City, the runways. It talks to us about how 16 right and 34 left, that is a 12,000 foot runway. It talks about that we have some de-icing pads over here next to it, the different taxiways. So Alpha, Alpha 3, Alpha 7, Alpha 8, Alpha 9. And then once again, 16 left, 34 right, 12,002 feet for the runway. And then 17 and 35, we have a smaller runway, so 9,596. We have some general aviation parking off to the side here. And then we have just some more de-icing pads over here. We have, let's see what else we got over here. We have an ILS holding right over here by runway 35. So there's just a lot of things that you're going to be seeing on that first page, which is that airport overview. When we talk about like the whole de-icing pads and where they are in relation to the runways, that's good to know just because let's just say runway 16 left and 34 right is the one that is going to be in use, right? Or the one that you're planning for. And then it didn't have a de-icing pad near it. Let's just say the closest one is going to be over by 34 left and 16 right. That's stuff that you have to take into account when it's winter operations, especially because you want to make sure like, okay, well, it's winter operations. They're probably going to need to ice the aircraft. We're probably going to have some extra fuel on board for the taxiing fuel. Wow, I cannot talk right now. For the taxiing fuel. So that's just something to kind of be more mindful of is where they are in relations to the runway and what runway that you're going to be using, what the traffic is doing at that airport, if it's a high volume airport or not, if you're going to be sitting down or sitting on the taxiway longer than you probably should be. It's just something to kind of keep in mind when it talks about like fuel planning. But then let's see, when we also look at this with the runways in use, right? When you do the flight planning part of everything, you're going to be choosing your departure runway. And if I'm not mistaken, you're going to be also choosing your which approach you're going to be using for which runway as well. So do you guys know how to choose which runway to go for? You can thumbs down, you can hit no in the comments or yes in the comments. Okay. So the way you're going to choose which runway to use or to plan essentially for, right? Because we're just planning everything. you're not going to know which runway they're actually using until the pilots start up that aircraft and they get the ATIS information, and they start talking to ground controls. So for planning purposes, what you would do, let's just say I'm going to go back to Salt Lake City here. Where am I going? I'm gonna just pull up Salt Lake City just so we can have like a real METAR on here. So the winds, you're gonna look at those winds, and right now you're gonna see that the winds are 280 at 4 knots. We're not really paying much attention to what the knots are doing. We just want to know what the direction is doing. So in this case, the winds are coming from 280. So when we're planning this, you're going to pick the one that's closer to that number. And of course, you know, based on this is just for planning purposes. Again, you're going to know tomorrow when Allison goes over those NOTAMs, right? If you're planning for a certain runway, you have to make sure in your NOTAMs that it is also usable, like that's not closed for whatever reason. Sometimes some airports, some runways are going to be closed. So if the winds are coming from 280, in this sense, you really wouldn't want to pick like 16 right, 16 left, 17, just because they're kind of like too far away from 280. So you're probably most likely going to be using or wanting to pick 34 left, 34 right, 35 even, or even this one 32. But just keep in mind, you also, if you have multiple runways that you could potentially use, don't go after this smaller runway. You want to pick the one that has like the most length to it. So in this case, you can, 34 right has the most just by 2. So it's just slightly bigger, but it doesn't matter which one you choose. You can do 34 left or 34 right. So you would just want to see where the winds are coming from, which direction, and you want to just match it up to which one has which runway is closer to that one. If that makes sense. Because you're going into the wind. You're taking off, or you're taking off into the wind. Yes. Everybody see how we got that? Perfect. Awesome. So then let's see. Try and think of everything we can possibly talk about on this chart. That you, at least that you guys need to know. The HS2, HS3, HS1. Do you guys know what that could possibly be? I got 1 thumbs up. Brian said no. Basically, it's just called hotspots. So these are where runway incursions can happen in these areas, and they name them for you. The hotspot 3 area, hotspot 1, hotspot 2, hotspot 1, and it tells us up here too as well, runway incursion hotspots. And then it even says see 10-9 for description of hotspots. Awesome. So we'll continue going down. They have, and again, like it has control towers, has fire stations. It's basically just going to give you that whole overview of this airport. So we're going to continue down. And now we're getting into the 10-9A. So it's going to have, sometimes it may or may not have notes to it. In this case, it has general notes. So it's going to say caution, birds in the vicinity of the airport. It's going to say paragliding in the vicinity of the point of the mountain. And then operated transponders with altitude reporting mode and ADS-B if equipped and enabled on all airport surfaces. So it's basically just going to give us a whole like general note section over here. Sometimes it will say, you might read one that says departures are not able to go between a certain time. So you just have to, like, you have time restrictions or hour restrictions, I guess, that you just want to keep in mind as to if this aircraft is taken off during that time, you're probably not going to be able to take off. So you might have to delay the aircraft. So you want to just read the general notes section, kind of just see like, is there anything pertaining to us that we would know that we would want to know about, which is going to be like those the hour restrictions if an airport is closing at a certain time, or if you can't have departures going at a certain time, arrivals at certain times. Those will also be in NOTAMs, but they would also write it up here on the general notes. Okay, so then continuing down, we'll just go down this list. So you have the additional runway information. This is telling us runway 14 and 32, what kind of lighting system there is, what the pavement is grooved, what the width is. And then we have runway 16 left and 34 right. It talks about, again, the different lighting systems, which I do have some videos that we'll watch. Just kind of explains them a little bit more. 16 right, 34 left, the different lighting systems, 17, 35, the different lighting systems. And then just keep in mind that when we go into the whole takeoff minimums, if any one of these lighting systems is off, it's going to affect our takeoff minimums. So if any one of these is an up, it will affect that. And Allison is going to dig more into that actually with you guys tomorrow. Then we go down to the runway incursion hotspots. That's something that we saw on the main body. It talks about hotspot 1, wrong runway departure risk, whole lines for runway 35 and 32 are at the same location as taxiway K1 and taxiway with a short taxiway distance. So it talks about those hotspots right down here. And then we're going to get over here onto the right side where it's the takeoff and obstacle departure procedure. So we have 2 engines. So the standard takeoff minimum is with 1 or 2 engines is RVR 5,000 or 5,000 or 1 statute mile. And this is visibility. Now it can go down and we can use lower minimums, but those are just the standards. So then it talks about the adequate visibility. If your runway center line marks or your runway center line or your HIRL, which is the high intensity runway lighting, or if you have adequate visibility. So then you can bring it down to the RVR being at 1,600 or 1/4 statute miles. And then it just talks about a little bit more what you can bring it down to based on the op specs. And then through our op specs, you can use, I think it brings it down to 500. So our touchdown zone RVR is 500, the mid RVR is 500, and the rollout RVR is 500. All right. Let's see. So it talks about that for different runways. So runway 16 left, runway 16 right, runway 34, and runway 34 right. What I'm going to do is I am going to have you guys look at different videos, and I'm just going to post them in here just because last time I tried doing this, it didn't work well with like the whole sound system. So I'm going to have you guys take a couple minutes and watch these videos because it explains more about the lighting systems. All right, so just take those 10 minutes. It should be 10 minutes long, so just take those 10 minutes and then look at those videos, and then I'll be right back. All right. Everybody, still watching them? Are you guys good on them yet? Okay, awesome. So those are just a couple of different of the lighting systems, and those can definitely affect the visibility, or they can definitely affect the minimums, the takeoff minimums. Let me see. And okay, so I'm going to share my screen in just one moment. Okay, let's see. So we have the different the standard takeoff minimums, right? With the 1 or 2 engines, it can be that RVR, the 5,000 or 1 statute mile. Or if we have all the lighting systems working, and we have adequate visibility, we can go down to, in this one, 1/4, or the RVR being 1,600. So it just talks about that for different types of runways are available. So runway 16 left, runway 16 right, 34 left, 34 right. And then again, the runway 17/35. For runway 14, your standard is going to be 1 statute mile. For the most part, it's always going to be 1 statute miles on the standard for the takeoff minimums. But then again, based on our if what your company has in their ops specs, it can go even lower than that. So when you read it, technically, if we're trying to take off of Salt Lake City, right, this one is reporting that the METAR is 10 statute miles. So we would obviously have enough to be able to legally take off and meet those minimums. And then my iPad did die, so just I don't have it plugged in yet, just because I am currently in a different area of the house right now. But if you have a question, just come off mute and just ask away, just because I don't have that extra set of eyes to see if you guys are asking questions or not. So going back to our 10-9A, it then talks about some obstacle departure procedures and some diverse vector areas. This is stuff that we really don't need to know. It's more for the pilots. What's really important is for filing as an alternate. So this is going to be what you're going to be looking for when you're looking at your takeoff alternates and you're looking at your landing alternates, right? We don't do an RNAV in this class, so we don't have to worry about that. So we're really just looking at the ILS or the localizers. If you see it has an NA, that means that can't be used for an alternate. So you would have to either find a different runway that has some type of letters or numbers to it. Or you would have to basically do, if it doesn't have anything and just says NA for the whole entire thing, you're basically just gonna have to find a different airport to go to. All right. So this is just saying that for the ILS runway 16 left, it has to be 600 for the sailings and 2 statute miles. That's the standard. And then the other one is 800-2. So what I'm going to do, just because I think it's easier to see it versus me talking about it, I am going to send you guys some more videos to watch. Give me just 1 second here. And Jaden is actually going to be coming in to finish the course just because I think I ate something that is just not sitting well with me. So I'm not feeling too good. So Jaden's actually going to be jumping on here within like 40 minutes to finish the class. But in the meantime, just go ahead and watch that video.
Hey everyone, sorry to interrupt your video. Hopefully you can hear me. Once you guys are done with the video, just take a break and come back about 45 after, and then I'll pick up from there. Sorry, I'm just driving home from work right now. So yeah, Joe, once you're done with the video, just take a break and jump on 45 after, and we'll continue on. So see you guys then.
I am also going to be putting in another video to be watching, this video is going to just talk about how, okay, this one you're going to learn a little bit more later on this week. It talks about the whole 1 nav aid and 2 nav aid rule. Basically, if we have an alternate that we're using, like a takeoff alternate or a landing alternate, what you guys are going to be doing is using that 1 nav aid or 2 nav aid rule. But that's going to be explained a little bit later down the line this week. And then, okay, perfect. And then Jaden hopped on. I'm so sorry, I had to step away during that moment there. But Jaden stepped on, I see, and he said he'll be jumping on the next 45 minutes. So that video is not really that long. If you want to watch that second video that I sent you in the message, feel free to. It's not going to make any just sense yet, just because I haven't explained it too much to you guys. But otherwise, if you want to watch that one that I just sent you, please watch it, because you're going to be learning about that later on. And then Jaden's going to come on and finish off those, the 10A, the 10-9A. But I guess in the meantime, he said that he'll be jumping on in the next like 20 minutes, it looks like. So if you're done watching that, just hang out, take a little break or so, and then just be back by like the 45-minute mark for him. I do apologize. I was not expecting to get this way. So I am so sorry, but you're going to be in great hands with him. So in the meantime, I'm going to leave this call on just until he gets in there, so you all can be in the group still. But just come back and at the 45-minute mark for him, and I'll let him know that you'll be back at the 45-minute mark.
Thanks,
And
Jen.
thank
Hope
you.
you feel better.
Yeah, thank you. Sorry about that. I was not expecting it, but thank you.
All right. Hey, everyone. Welcome back. Sorry about craziness of tonight. But how's everyone doing? I'm awake still. Now this time of night it's a struggle bust. So all right. So I'm not 100% sure where she left off at. What were you guys talking about when
She was kind of showing us the 10-9A page and the yeah. So she kind of going through those and they're going through that, and she had us watch a couple of videos related to it as well.
Okay, perfect. What stood out from those videos that you guys saw? Anything crazy?
Well,
Nothing
the
so
last couple of them were kind of stuff we've already. It was the 1 and 2 navigate rule, just kind of
Okay.
going over that again. The first 2 though had to do with the lighting systems, and for me anyway, it was a nice visual aid because I'm not as familiar with all that stuff. Being a non-pilot.
It was the lighting systems on the runways, stuff like that. The approach lighting
Yeah, like
system.
yeah, and the approach, yeah, all that. It's good explanations about all that.
Okay, perfect. Awesome. Well, yeah, so it's the theme of tonight, right? Obviously, is we're learning about approaches, we're learning about takeoff minimums, looking to see where we need to take off alternate, and finding the place where that information is at. It may not seem like important, but it actually is a pretty important part. If you think of flight and you think of the most critical phases of flight, does anyone know what the most critical phases of flight? And what do I mean by most critical? Okay, the most critical phases of flight is, I guess, what you could say is the most important phases of flight, where if something were wrong to happen, it could be catastrophic. I mean, I guess that could happen at any point in the flight, but it's really, there's 2 main phases of flight that typically, if something bad is going to happen, it's usually at these 2 phases. Does anyone know what that is?
Takeoff and landing.
Takeoff and landing. Exactly, right?
Landing, there's more, I guess, incidents, but takeoff, there's more fatalities.
Yep.
More catastrophic during takeoff.
Yeah. So now why is that, right? So takeoff, you're starting on the ground, you get onto the runway, you get clearance for takeoff, and all of a sudden, you go to takeoff power. So you spool up the engines, and that's usually where, right, when you spool up the engines all the way and you start hauling down that runway, that's usually where you're going to get an engine failure, right? For the most part, because that's when the most amount of stress on the engines is at that takeoff thrust settings, right? So that's one thing. 2, if you have an engine failure or something like that, on takeoff, right, you are very close to the ground, right? So you have a lot of stuff going on. There's a lot of points of potential failure, right? So you could have an engine failure. You could have a failure with your landing gear. On takeoff, they may not retract. You can blow a tire. X, Y, and Z. You can have something like that, and you could have to abort takeoff. So, right, you slam on the brakes, and you come skidding down the runway and trying to stop on that runway, right? You could, if you, for some reason, you make the call too late, or you have a short runway, you could end up going off the end of the runway. Anyway, you guys kind of get the picture. There's a lot that can go on. So that's why these takeoff and landing, right, are the most critical phases of flight. So we want to make sure that we're putting ourselves in a safe situation in order to take off, right? So there's certain weather requirements that we need in order to safely take off, that we could deal with one of these situations if it came up, you know. So that's kind of where this comes up. So we can take off in a lot lower visibility than we can land in. I'm sure, as you can see, that she probably went over takeoff minimums a little bit. I'll pull up, let's see here. Let me pull up some more charts. So again, you can take off in next to nothing visibility. This keyboard is dead. Let's take a look at Denver. How about that? So yeah, so you can take off next to nothing visibility. Typically what you need for takeoff is about 500 RVR. So if anyone familiar with so RVR is your runway visual range, meaning that you can see 500 feet down the runway. That's typically what is required minimum for our takeoff minimums. Does anyone have an idea kind of how that relates in terms of statute miles visibility that you'd see in a METAR? Share this here. Well, it's next to nothing visibility. It would end up being 500 RVR. So if you look at one of these charts, let's just go to.
That's not even an eighth of a statute mile. Even less
Yeah,
than that, isn't
like, so for example, like this approach right here. Oh, come on. Hit the back arrow. I hate when I do that. That's the one downside of using trackpad. If you go back, it will. Yeah, so I'm just pulling up a random approach here in Denver. So 18, right, it has the RVR equivalents roughly with the statute miles on this approach. So right here, right, 1,800 RVR is equivalent of about a half mile. So if we're going to about 500 RVR, we're looking at like somewhere between 1/32nd to 1/64th of a mile. Just quick and dirty math, right? So that is super, super, super low. Just close the door, Hannah. Huh? Okay, close the door. So anyway, so that's that. So that's about roughly what we need, somewhere between 30 seconds, 64. Are you ever going to see that in a METAR? Absolutely not. I have seen some places where it's been reported 0 statute miles. So, but this is where the RVR comes in. You can really kind of get dialed in on the RVRs where you wouldn't necessarily see that in the statute miles. So that's kind of what we're talking about when in terms of takeoff minimums. So we always go to our 10-9 alpha chart. So here's Denver's. So there's 2 main parts of the 10-9. As you can see that this is kind of broken off into 2. This left-hand side is just trying to make this big so you can kind of all see it. My number one pet peeve is, especially when I'm online or learning from a class, that I can't see whatever the instructor is presenting. So I try to make it as big as possible and try to point out where I can. So, so this on the left-hand side of this page is the additional runway information. Okay, so it gives you all the rundown of all the runways, the particular lighting systems. So for example, this one runway 7 here. So we have our runways right here. So this is 7 and 2.5. You have your HURLs, which is your high intensity runway lights. You have centerline lights. and you have a Mauser. The Mauser is the particular lighting configuration of the approach lighting system on this. You have touchdown zone lights, and then you have a PAPI. Anyone seen what a PAPI looks like? I'm not sure if that popped up in any of your guys' videos that you watched today. Chris said, yeah. Bruce said, yeah. Yeah, you guys all seen a PAPI, right? So it's the 4 red dots on the side of the runway, and it basically tells you how high or how low you are in comparison to the glide slope. If you got 2 red and 2 white, it means you're right on the glide slope. And then those dots change if you're too high or too low. That's really all you need to know about the PAPI. This will tell you, it's important to know which side of the runway it's on. And this is telling you the PAPI is on the right-hand side of runway 7. This gives you the glide slope angle, which is 3 degrees, and then tells you if RVR is reporting. So you have your usable lengths of the runway when you're landing beyond the glide slope. So again, here's your those distances, and then you have your runway width. So this is kind of the quick and dirty, all information in one spot on every single particular runway. And it goes through all of them, right? Then you get to the section, which is our takeoff and obstacle departure procedures, right? And this is, if you see takeoff and obstacle departures right here, AKA those are your takeoff minimums, okay? So if you're in a GA aircraft, you're flying a Cessna, right? You are in this box right here, your standard takeoff minimums. Sorry, it's really hard to draw the trackpad. So you get your standard takeoff minimums, right? And you determine how many engines you have. So how many do we have on the CRJ 700? 2. Yeah, perfect, right? So we'd fall under this box. And according to this, our standard takeoff minimums is 1 statute mile or 5,000 RVR, okay? So we have, you guys remember from week 1, we talked about our operation specifications. In our op specs, it allows us to go to lower than standard takeoff minimums, provided we have certain lighting equipment available for us, okay? So we can go down to 1,600 RVR or a quarter statute mile, provided, right, we have our runway centerline markers or centerline lights or high intensity runway lights or adequate visual reference. So any of those, you have one of any of those things right there. Now, all of a sudden, your takeoff minimums go from 1 mile or 5,000 RVR down to 1/4 and 1,600 RVR. Okay. So basically, all you have to do is, in order to know if you can use the 1/4 mile or 1,600 RVR, you go up to your runway. So this one is specifically talking about runway 34 left, right? So we can go up to runway 34 left and make sure that we have any one of those things. Well, here we go right here. 34 left, we have our hurls. Boom. Right? Then we just have to make sure that we go into our NOTAMs, make sure that those are operational. If those are operational, then we could use this 1/4 mile takeoff minimums. Any questions on any of that so far? No, that's probably a lot in a very short amount of time.
Did you say what adequate visual reference is?
Yeah, so adequate visual reference is you can see everything in front of you and around you. Essentially, if you have a 1/4 statute mile visibility, then it's you can see adequately, right? Have visuals out, then you can consider that adequate visual reference. So usually we don't. This is kind of more probably up to the pilot to determine that. Usually this is actually an example of something we don't see very often. Usually it doesn't say or adequate visual reference. Usually it will call these takeoff minimums just your adequate visual reference takeoff minimums, because that's what it usually says. So this one's kind of a catch-all with all those. So hope that answers your question. So any other questions about any of this? And hopefully, am I repeating everything that Jen did already? I don't want to be doing that either. So
Not really. She didn't get too much into that.
Okay, perfect. All right, so now kind of just threw you one curveball. Let me throw another one at you. Okay, see all these numbers? We got the rest of these numbers over here. Sorry, really bad. bad. Okay, so we figured out what this box means and this box means, right? Basically, and this is again going down to what specifically our op specs say that you can do. We're using the SkyWest op specs, and so their op specs, they can go all the way down to 500 RVR, provided right here that they have their centerline lights and their high intensity runway lights working, right? So again, if we're using this runway 34 left right here, we would go in, we check our NOTAMs for runway 34 left to make sure that our center line and high intensity runway lights are working. If they're working, then we could go down to our takeoff minimums of 500 RVR. Now, here's the caveat. When we go down to this low visibility, we have to have at least 500 RVR on our touchdown zone, our midpoint, and our rollout, right? So those are our 3 reporting points of our RVR on a runway. So again, our touchdown zone is where you, right, touch down. Midpoint is the midpoint of the runway, and rollout is the far end of the runway. So as long as we have 500 RVR on all 3 of one of those points, and it's in our op specs, and our center line and our high intensity runway lights are working, then we can go all the way down to 500 RVR. Okay. Any questions about that? I know it's a lot. Yeah, Brian.
Is on the one to the left that says HUD as well? Is that heads up display? Or is that
Yes.
something else? Okay.
Yep. That's heads up display. We don't have one in the CRJ, but there are some aircraft that do have the HUD. It's common in the 737, the 787. There's some other aircraft that have it as well. So, yep. So yeah. So if you had a HUD and your op specs allowed you to, along with your centerline and high intensity runway lights, then you could go down to 300 RVR. So our 7-3 fleet at Delta can go down to 300 RVR. So there's that. Good question. Any other questions on this? Okay, so now going back to the big picture. Well, Jaden, that's a whole bunch of numbers on there. Which one would we actually use for our takeoff minimums, right? Well, the key word here is you want to use your lowest takeoff minimums that you have available to you, right? So usually what you'd end up doing is you'd probably come down, okay, I know my op specs say I can go down to 500 RVR. Let me check to see if my centerline and high intensity runway lights are working. If they're working, perfect. You can go down to 500 RVR. No questions asked. You're going to take off, no problem, right? If one of those isn't working, then you go, okay, well, do I have one of those working? If one of those are working, then we can still, Jesus, that's terrible. Wish my mouse didn't. My mouse and keyboard died at the same time. What are the chances? So it's just one of those days. I'll tell you about a situation I had working today too. That was pretty crazy. It'll help you know what to say and not to say on a plane. It could end up getting you in trouble. Anyway, so if you have one of those centerline or high intensity runway lights or runway centerline markers, then you can use the 1600 RVR or a quarter mile and you're good. So if you don't have any of those, then you'd use your standard takeoff minimums, and that's kind of what I would do. So in this case, we'll just pretend everything is operational. So our takeoff minimums would be 500 RVR is what we would need for takeoff minimums. Any questions on that? So again, basically the process that you go through is one, right? What I like to do, and you'll get to see more of a feel for this next week when we start getting actual flight planning. Let's say we're departing out of Denver. What I'd do is I'd look at my winds, I'd look at my NOTAMs, and what I'd do is I'd pick my runway, right? Then once I know the runway that I want to use, then I'd go through here, find the runway that I picked, right? As you can see, these numbers are specifically for 30 for left. These numbers are specifically for 30 for right, 30 for left. This one's right. And you just find the one for the runway that you're planning on using. And that's it, right? And then you can come over here to the other ones kind of continue on the other side of the 10.9 alpha page. So there's that. And then, yep, find the takeoff minimums for the runway you're planning on using and write those down. And that's how I'd go with that. So any questions on takeoff minimums, right? So if you're ever getting down to the situation where you have to look at your takeoff minimums, I'm just going to tell you, you probably should be picking a takeoff alternate, right? If you ever started to get it in so far in the weeds that you have to start looking at your takeoff minimums, again, you can take off in next to nothing visibility. You're getting close to where you don't have landing minimums anymore, right? Because that's when you need a takeoff alternate, when you don't have your when you don't have your landing minimums at your departure airport, you need a takeoff alternate, okay? So there's that. Now, can you put on a takeoff alternate at any time, even if you do have your landing minimums? Yes, right? Don't be afraid. It doesn't do anything. It doesn't add any additional fuel. It's just giving your crew a backup plan, right? We talked about takeoff as one of the most critical phases of flight. When you take off, the last thing they want to do with something happening, one, they don't want to be coming back to an airport with crappy weather, right? You're just adding onto the complexity of the mission by having possible engine failure or whatever it might be happening. It's going to be some type of, pretty severe mechanical emergency for them to immediately decide they're going to have to come back and land immediately, right? So if they're in that situation, they're coming back to an airport that's in crappy weather, right? You're just asking for trouble, right? So again, the reason why we go through this and we figure out, okay, do I need a takeoff alternate or not, is basically what it comes down to. It's just everything is planned out ahead of time so that when something happens, you know what the plan is and you execute said plan, right? That's the goal of everything that's going on. So if you have a crappy weather where you're taking off from, let's use Denver, for example. Colorado Springs is a hop, skip, and a jump away, right? Okay, let's plan if anything happens while we're departing out of Denver with bad weather, which there's a lot of days in Denver where they have crappy weather, fog, thunderstorms, whatever it might be. They take off, something happens. Hey, plan is we're heading straight to Colorado Springs. No questions asked. We've already planned for it. Colorado Springs is great. We already checked the NOTAMs. We already checked the weather, right? We execute the plan if that happens. That's the whole goal behind having a takeoff alternate. Because the last thing you want to do is, you have an engine on fire. You look at Denver's weather. Crap, we can't legally land anymore. Well, honestly, you probably don't care at that point. You're just going to get on the ground anyway, right? Declare emergency. But again, you don't want to make that problem any worse than it has to be. Because if you have an engine on fire, you can't see the runway that you're trying to land on, right? The chances of surviving that are not great, right? So again, I'm not trying to put doom and gloom on everything, but just trying to put this is why these things are put in place and why they are the way that they are. So again, you take off out of an airport, you want a solid backup plan. If the weather's crappy, right? If the weather's great, no problem, right? Okay, there's my short little jaunt on takeoff alternates. Anyone have any questions on that? Takeoff alternates, why they're needed, all that fun stuff, since we're talking about takeoff minimums and kind of that phase of flight. Anyone remember what the 3 parameters of a takeoff alternate are that you have to meet in order to list it as a takeoff alternate? I know this is a review from week 1. It's been a while. All right,
Give it a shot.
yeah, go for it.
So for two engine aircraft, it needs to be within 1 hour with engine out cruise. Or three or more, then it's 2 hours, within 2 hours or less at normal cruise. Needs to be listed in your authorized airports. The weather needs to be. I don't remember what the weather needs to be exactly.
Sure. Well, it's just three things, right? So one, we'll just stick with the two engine definition since that's what we're using for this class, right? Needs to be within an hour, right? So that's the first part. So again, think of when we need a takeoff alternate. You take off, something happens. It's in a situation where you're going to have to get on the ground quickly, right? Some type of emergency, whether it's a mechanical issue, medical, whatever. You're trying to get on the ground quickly. So you don't want to go more than an hour, right? Worst case scenario, what is going to happen? You have an engine out, right? So you want to be able to get to wherever you are planning on going with one engine out. Second, or the third part of that is in normal cruise speed in still air. And you go, well, Jaden, why the hell would they throw that in there? Okay. Well, we'll see next week once we start crunching the numbers more. We're going to do flight planning, and what we're going to take into account is our winds aloft, right? And how the winds affect our flight time, our speed, all that fun stuff, right? So depending on the day and depending on the winds, right, that hour to your takeoff alternate, that would change every day if you account for the winds. If you have a strong headwind, well, now your alternate choices are now only 50 miles. If you have a strong tailwind, then you can go 150 miles, right? And so could you just imagine that goat rope every day trying to figure out, well, what are the winds today and how far can I go for a takeoff alternate, right? And they said, no. We're not going to worry about that, right? What we're going to do is we're just going to say, what is within 1 hour with one engine and op under perfect conditions, right? With not taking the winds into account at normal cruise speeds, right? Whatever the normal cruise speed is for that aircraft. What is 1 hour away distance based on those conditions from Denver? Those are all the airports that you can list, right? You're not taking winds into account. You're not getting into the weeds, right? That's the whole goal with this. You're not digging in the weeds because, again, whenever you're going to be using this situation, it's going to be a bad situation, right? You don't want to be digging through the weeds, going through stuff that you don't want to. Again, you're planning this all ahead of time, but that's the goal. So any questions on that? So again, with one or not more than an hour, again, emergency situation, worst case scenario, one engine and off. You want to make it there with one engine in a short amount of time. And then again, you're not taking those winds into account and you're just using normal cruise speed again. So those airports that you can use that were within 1 hour of Denver, those are the same every day and they're not changing based on those winds and the conditions. So that's the thought process behind that. So any questions on any of that? Does that make more sense to understanding that part of it, or did I just confuse everyone even more? Okay. I got a couple thumbs up. Well, thanks for helping me feel better about myself. I appreciate it. Thank you. I'm here all week. So yeah, so that's okay. So that's kind of the quick and dirty takeoff minimums, takeoff alternate. While we're here, let's talk about filing as an alternate. Okay. Everyone thinks that this is kind of big and scary. It's not. Okay. How do we calculate our alternate minimums again? Can someone remind me?
One
One
navigate, two
navigate or two navigate rule.
One navigate, two navigate rule. Okay, perfect. So that's how we do it. Again, that is because we have in our op specs, right? Again, an exemption from the FAR that allows us to calculate our own alternate minimums, provided we follow the 1 navigate, 2 navigate rule, right? If we didn't have that in our operation specifications that would allow us to do that, these right here would be our alternate minimums, right, for these approaches. So these would be, right? So if we're using the ILS for 16 left, this would technically be our alternate minimums, right? But again, throw it out the window. We don't care what any of these numbers mean. Sorry, I'm trying to scribble these out. All we have to look for is, does it say that we can use these approaches for alternate minimums? We just have to see if it's available. At some airports, you'll see, some approaches have a big NA. And it says, you can't use this approach to derive your alternate minimums off of. So all you're doing is when you're picking, using the 1 navigate, 2 navigate rule, right? You determine, are using the 1 navigate, 2 navigate rule. Has anyone gone over that of how you decide between the two, which one you're going to use?
I think it comes down to which is going to give you the lower minimums, right?
Right.
Pretty much.
Pretty much, yeah. Let me give you the quick and dirty the way that I do it, okay? At least my thought process. And if it helps, great. If not, then at least I tried. All right, so here's the thing. Okay, so let's take the 1 navigate rule, okay? So the 1 navigate rule, we add how much to our minimums? So we have 1 navigational facility, 1 runway, straight in instrument approach, right? We add what?
400 in a mile.
Yep, 401. Perfect. So taking our standard ILS approach, which is 200.5, right? Our lowest alternate minimums are 601.5, right? Using the 1 navigate rule. That's the lowest you're ever going to get with the 1 navigate rule, okay? So think of the weather. How is it at 1.5 miles and 600 feet? Is that good? Bad? In between? What do you guys think? You're getting borderline crappy weather, okay? So here's my thing. If your weather's below, right? Okay, if your weather is at or below, right, the 1.5 and 600 feet, what you'd have to do, right, then you should just go pick a freaking different alternate, right? If it's above that, you're using the 1 navigate rule. Cool, right? Easy peasy lemon squeezy, right? There's a whole hell of a lot less work that you have to do with the 1 navigate rule, right? So if I can use the 1 navigate rule, I'm going to use it. If I can't use the 1 navigate rule, I'm taking a different freaking alternate, right? Because I'm getting crappy weather, right? Okay, so that's that. So 95% of the time, I use the 1 navigate rule, okay? Now, let's say, which this happens every so often, we get a big bomb blizzard that's sitting right over Minneapolis or the Northeast, right? And every single airport around JFK or Minneapolis or wherever it is all just, you're in the fractions, right? Low visibility, low ceilings, but you have to find an alternate around those places, right? The whole region is just socked in with fog and with snow and all that fun stuff, right? Okay, then I'm going to go through the work and try to use the 2 navigate rule, right? But that's the only time that I'm going to do that, right? So that is my key, okay? 95% of the time, I'm going to use the 1 navigate rule. If I can't use the 1 navigate rule, guess what? I'm going to pick a freaking different alternate. If I can't do that, then I'm going to go through the work and trying to use the 2 navigate rule, okay? So that's my rule of thumb. That's the way I look at it. Again, sometimes you're going to have to use the 2 navigate rule. Now, the 2 navigate rule is a lot easier to use at big hub airports, right? You have a lot of runways, you have a lot of approaches, a lot of ILSs. So it's not hard using the 2 navigate rule at a big hub airport like in Atlanta or Denver or Seattle or JFK, right? If you know you pretty much are going to have your 2 NAVAID rule, and it's going to be 401 at those big hub airports, so it's not a problem. However, and I'm not sure how much you guys talked about alternate minimums, but a lot of times you'll actually get higher minimums using the 2 NAVAID rule. Did you guys talk about that before? You can get a lot higher minimums using the 2 NAVAID rule than even the 1 NAVAID rule at some places. Like St. George, for example, is that, and we'll get into more detail with that in St. George, but they only have an LDA on one side and they have a VOR approach on the other. So again, using the 2 NAVAID rule, you have to take the highest ceiling of the 2 approaches and the highest visibility of the 2 approaches. So you really only have one good approach on one end, and you have astronomical mins on the other side. So you have to add that to these super high mins. And so you can get a lot better alternate minimums in St. George using the 1 NAVAID rule than the 2 NAVAID rule. Okay. So just something to keep in mind. We'll get into more detail with that over the next week in the flight planning and into the in-person portion of the class, but that's how that goes. So again, recap, 1 NAVAID, 2 NAVAID rule. 1 NAVAID rule 95% of the time. If you can't use the 1 NAVAID rule, take a different alternate. If you can't pick a different alternate, then go through all the steps of the 2 NAVAID rule, pick 2 navigational facilities, 2 separate but suitable runways, right? Suitable means you can't have more than a 10 knot tailwind, right? So you have to go through the work, check all the NAVAIDs of the approaches, make sure they're both different. You have to go in here and make sure both approaches are okay for filing as an alternate. And then again, you compare the 2 approaches and you add the 200.5 to the highest ceiling of the highest visibility of the 2 approaches, right? You take the worst ceiling of the 2, worst visibility of the 2, add those minimums, and then that's what you get for your alternate minimum. So again, it's a lot more work. If you don't have to do it, again, don't do it, right? This job is all about working smarter, not harder. Okay, it will save you a whole lot of time and heartache if you learn a few simple tricks, right? So there's that. Okay, talked a lot. Any questions about any of that so far? All right. Let me see here. Let me see. I think we talked about. Did Jen go over the 10-9 chart as well? Kind of airport overview chart. Perfect. Kind of layout, all the runways, all the taxiways, the terminals, fun stuff. That one's pretty self-explanatory. But this is a great resource to know, right, where you're going, where the de-ice pads are at, kind of get the lay of the land for where gates are at and all that fun stuff. So there's that. One other mention that I will mention, because some people freak out, is this chart right here, again at the top. It's just a red real fast. Make it pop a little more. So this is called the 10-9 alpha, right? But it's not always called the 10-9 alpha chart for every single airport. Okay. Seattle, for example, is called the 29 alpha chart. Kind of interesting. So if you see a 29 or a 39 alpha, whatever, it's the same chart, right? So I don't know why they do this way, but if you get a city that has multiple airports, the first airport that was there gets the distinction of having the 10-9 alpha chart. Okay. So in Seattle, they have Boeing Field right next to SeaTac, right? So Boeing Field has the 10-9 alpha chart for their stuff. And SeaTac or Seattle Tacoma, right? They have the 29 alpha chart. They're kind of the redheaded stepchild, right? They're the second one there. So they get the 29 alpha. And so you'll see that in New York and DC and stuff like that. So if you see that, you're like, I'm trying to find the 10-9 alpha chart, and this is 29 alpha or 39 alpha, right? It's all the same. Just remember something and 9 alpha and you're on the right chart. Vast majority of airports, it is a 10-9 alpha chart. But some of those, again, those bigger cities that have multiple large airports, you'll see a difference in those charts. So that's pretty much all you need to know about takeoff and all those fun things. So, well, thanks for being patient tonight with everything. I'll leave you with a quick story about what I had to deal with at work, what I literally walked into. So, got to work and I was working the Caribbean. So I was doing flights down to in and out of San Juan, Puerto Rico, Puerto Rico, the DR, so Dominican Republic, Aruba, Curacao, Grenada, a lot of those islands there in the Caribbean. And walked in and we had multiple flights diverting from Aruba. So that was the desk I was working that had all the Aruba flights. And this was a jet. You may have seen it on the news if you. But anyway, JetBlue, they had a bomb threat. Okay, so on the way into Aruba, shortly before descending and go down, a passenger went into the lab, came out, and they mentioned that there's a bomb in there. I'm not sure if they said, I just dropped a bomb or whatever, right? But whatever it was, whatever they said was very concerning, right? So again, this is when I talk to you about what you say, certain words when you're on an airplane. Came out, of course, alerted the flight attendants, and I'm not sure what they did. Ended up closing the lab. They ended up landing in Aruba. They didn't want them anywhere near the terminal, so they had them go off and sit on a taxiway, right? All alone by themselves. Well, Aruba, guess what they decided to do? They said, you know what we're going to do? We're going to close the airport for 3 hours. So all of our inbound flights, right? The airport's closed. We got to start diverting them. So we send them one to Curacao. We send one to Punta Cana. We had flights that were stuck on the ground in Aruba, had them return the gate. And while they dealt with this, so it took a while. They ended up deplaning. I'm not sure whatever happened with it, but again, it all came from someone. I'm not sure if they're making a joke or whatever, but it came out of the lab and mentioned that they dropped a bomb. So be careful what you say on airplanes. It can get you in trouble, and it's cost a whole hell of a lot of money for Delta Airlines today, let alone JetBlue and all these other airlines. Because again, we may know that's a joke, but you don't want to be the dispatcher or the flight attendant or the pilot to go, "Oh, I think they're just joking," and then find out it not to be a joke, right? So we always have to take everything seriously. Again, it never hurts to take a safety time out, check things out, make sure that everything is safe before we proceed, right? We don't want to be in a situation where, again, we think they're joking and they're not, or whatever, and not take something seriously when we should have. We'll look back on that for the rest of our lives and regret it if we don't. So, but anyway, so that caused a whole lot of problems. So there's your PSA. If you learned something today, don't say that on an airplane. Don't say that in an airport. Probably not in a courthouse either. I'd probably avoid just saying it anywhere, but for sure in a place where that is a safety sensitive place. So anyway, so sorry I went over on time, but yeah, deuce or yep, for sure. Whatever that way. So well, I'll be sticking around for the next little bit, answering any questions that you guys have. Thanks again for being patient tonight. I hope you guys have a great night. And I'm teaching on Friday, so I'll see you guys on Friday. We'll go over doing a review and whatnot. So I'll stick on, but have a great night, everyone, and we'll see you on Friday. Thank you.
So Jade, I have a question.